Okay, so we're going to go through trig identities. A lot of times when they tell you guys to start this stuff, they tell you to use your equal sign kind of as a middle or medium, and they talk about solving a left side and a right side of an equation. Is that familiar? Yeah, okay. And a lot of times they'll tell you just to work with one side of an equation, okay? Which is not a bad idea. They might say just go to the left side and eventually get it so that it is equal to what this right side is. In this case, the right side is relatively simple, but say we had a rather large equation again on the right side. Sometimes it's not bad to kind of work with both of them until we get some type of equivalency down the road, okay? Because it can be sometimes very difficult or a very long route from one side to the end of the other, okay? So like I said, we have to have a decent working memory of some of the rules. So there's one quick rule. I look at the numerator here of the fraction on the left side of the equation, and 1 plus tangent squared x. Do you know what that's equal to?
Secant squared x.
That's right, secant squared x. So right away off the bat, I'm going to take this and I'm going to simplify it so there's just one trig identity instead of adding one. There's another one, the one on the bottom, the denominator, 1 plus cotangent squared x. Do you know what that's equal to?
Cosecant squared x.
All right, cosecant squared x. Okay, so both of those, right off the bat, I'm going to replace, okay? So the one on top now becomes secant squared x divided by, and on the bottom we have cosecant squared x. Now, again, they don't tell you that you have to continue to write out the right side. I'll probably keep it in mind. For now, we'll just kind of put a redundancy thing here. So we have secant over cosecant squared x, okay? Now, what I'm going to do is, personally, I'm much stronger working with the basic trig identities, or things known as sine, cos, and tangent. So I'm going to try to relate these, our secant and our cosecant. I'm going to try to relate them to these because I find it easiest to work with those. Plus, I remember more rules with these than I do secant, cosecant, and cotangent. Okay. So do you know an equivalency for secant squared x?
1 over cos x.
That's right.
Cos squared x.
Okay, great. So we can go secant squared x is equal to 1 over cos squared x, right? And you could look at it as the 1 being squared too, but won't make any difference in this case, okay? And what about cosecant squared x?
1 over sine squared x.
That's right, 1 over sine squared x. Okay, so what's going to happen now is we're going to have essentially a fraction when we replace this fraction here, over another fraction, which can be confusing if I write it as essentially a fraction over another fraction. So instead, I'm going to rewrite this. This fraction sign stands for what? Do you remember?
Division.
A division sign. So I'm going to replace this with a division sign. And now I'm going to be working with 1 over cos squared x divided by 1 over sine squared x. Okay, and it's still all equal to tangent squared x. And it's easiest, now what I'm going to do is I'm going to work with my fraction rules. Since I know my fraction rules, if I'm dividing, how can I simplify that? Do you know how to, or how do I equate a division? What would I do?
It's the product of the reciprocal.
That's right. So the first number we keep the same. So we have cos squared x multiplied by, and we flip our second fraction, sine squared x over 1. Okay? And when I simplify those, we're going to get sine squared x divided by cos squared x. Now, these are both squared. Okay? And there are trig identities for things that help us with squared. And now I'm just going to bring us back up to the top here, our tangent squared x. I'm going to bring that down. Okay? Now, technically, they haven't given us a rule like this, where they're squared. So one way I could simplify this, because I do know a rule stating that tangent x, when it's not squared, is equal to what?
Sine over cos.
Yeah, sine x over cos x. Okay. Now, we're not technically there, but it's pretty obvious to see that this is how we can do it. And again, if we want to simplify it to this version here, I can essentially, whatever I do to one side of the equation, I can do the other. So this is where it kind of came in handy working on both sides here, okay? Because when I was able to square root both sides, we end up with our trig identity we have at the end here of sine x over cos x is equal to tangent x, okay? And again, they probably tell you to make the left side tangent x. But in the end, notice I did go back to the right side just to simplify it a little, okay? Just because it would have been another 2 or 3 steps, because I would have square rooted this to make sine cos, then I would have equated it to tan. Well, if I square rooted it, I would have had to square root both sides. So it became a little confusing at that one point. So it wasn't a bad idea to actually use both sides of the equation there. Does that one make sense? Yeah?